Swayam Prabha. Digital India. Educated India.
Welcome to the course Mechanics of Solids. So, as we were discussing about the truss, analysis of truss, plane truss in the last couple of lectures. So, in the last lecture basically we have seen that how we can solve or analyze a particular say plane truss, right. So, and we discussed about method of joints, and today we will be discussing about the method of sections. Okay. So, method of joints, I hope that you have understood that how we can proceed okay, joint wise in the truss to get the solution. Solution means the member forces. So, those are basically the unknown forces, and under the action of some external forces you can calculate or you can determine the member forces if you analyze all the joints, right. So, in the last lecture we have seen that. So, today we will be talking about method of sections. So, first we should know what are the different properties or different say important say aspects of this method. So, first one is that the section, from the name itself it is very clear that we are going to choose some sections. Okay. Now, there are some properties of these sections. So, first one is that section can be straight or curved. So, there is no restriction how you are choosing the section. Okay. So, there are several guidelines for choosing the section, but section can be straight line or curved. Okay. The next point could be in contrast to the method of joints. One or more equilibrium equations. Okay. So, in method of joints you have seen that you have used equilibrium equations or you have considered the equilibrium condition at each and individual joint, right. So, in contrast to the method of joints, basically here in this method you may have one or more equilibrium equations. Okay. So, here basically we will see later on that you can exploit the equilibrium condition with respect to the moment also. Okay. Then the third point is that generally section cuts three members. Okay. So, you will be choosing the section in such a way that it generally cuts 3 members. Okay. More than 3 members you should not cut, but of course, this is a general statement. So, sometimes you may cut 4 members or maybe more than 4 members. So, that depends on the truss configuration, that even if you cut 4 members still you can get the solution, but most of the times if you want to get the solution then you should have the section which is cutting 3 members, okay, maximum 3 members, because you can explore 3 equations of equilibrium, to force equilibrium like summation of Fx equal to 0, summation of Fy equal to 0, and moment equilibrium like summation of moment with respect to some point is 0. So, there are 3 equations. So, therefore, generally the section should cut 3 members. 3 members means there will be 3 unknown forces which are going to be determined. Okay. So, these are few aspects of method of section. Now, let us see how we can proceed. So, we will take one example of truss. So, let us take this truss. This is a roller support. Okay, so this is one simply supported truss, plain truss. Okay. At G and H you are having supports, at G you are having hinge support, and at H you are having roller support. And there are three externally applied forces on this truss. One is 1000 Newton at A, which is acting perpendicular to the member AC. Okay. And then there are two 500 Newton concentrated force at joint E and F. Okay. And this span, all this span is I mean are equal. Okay. So, G double prime, E, B all are equal. The total span of the truss is 60 meter. Okay. So, just for the sake of illustration we are showing this, we are not going to solve each and individual numerical values. So, now in this truss basically if you look at, by using your method of joints you can solve this, there is no issue, but the main problem is that in method of joints, as I told you, that method is little bit cumbersome or little bit say lengthy process. Okay. Suppose if you want to find out the member force AB, what you need to do in method of joints? You have to start from say joint G and gradually you have to proceed from joint G to G prime, then G double prime and so on, and up to say A or B, whatever joints you consider, and then you find out the unknown force AB, or if you can move from H and then you can gradually move to member AB. So, this is a lengthy process, but in method of section, okay, if you want to find out the member force AB, very simply you can get it. Okay. Now, in this method of section, what is my first job? First job is to draw the free body diagram. So, we are not violating the first step. So, the first step is that to draw the free body diagram. So, if I want to draw the free body diagram, so basically what we can do? We can remove the supports and we can put, and if this is my xy coordinate system, this is hy and this is gy and Gx. Okay. So, these are the support reactions. If you remove the support conditions, you will be getting the support reactions, and now it will show you the free body diagram of the whole truss. Fine. And now you are well equipped to find out these support reactions. How you can find out the support reactions? Just to exploit the equilibrium conditions, and you will get 3 equations: summation of f x equal to 0, summation of f y equal to 0, and moment with respect to any point G or point H, you can find out the support reactions. Okay, fine. So, that is just for sake of completeness I am telling you, but rest of the next point onward we are not going to discuss how to find out the support reactions. So, automatically you know that you are supposed to find out the support reactions at the first moment. Okay. So, now once you know the support reactions, now basically you can choose different sections. Okay. So, let us take the sections. The first section, say, as I told you, section can be straight line or curved. Here section 1 is curved line, and it generally section cuts 3 members, right. Generally section cuts 3 members. So, it is cutting 3 members. This is 1 member, 2 member and 3 members. Okay. So, it is satisfying all the conditions whatever we have discussed for method of section. Similarly, I can choose some another section. So, let us say this is another section, section 2 2. Okay. I want to show that all the times you need not to cut or need not to take the section which is cutting only 3 members. You can even take a section which is cutting 4 members, but some proper or some specific configuration. So, now if you look at section 2 2, basically it is cutting 4 members, member BE, member BD, member AB and member AC. So, 4 members are getting cut by section 2 2. Similarly, one more section I am considering. So, these 2 sections are carved. One more section I am considering, that is section say 3 3, and that is nothing but a straight line. Now, what to do with these sections? I am cutting the sections, fine, but what to do with the sections? Okay? That will be discussed now. Now, if you take the sections like that, basically our job is to take, once I take the section, I can take the right hand side or the left hand side of the section, and we can analyze that part, the left hand part or the right hand part, okay, to find out the unknown forces. Now, if you look at section 1 1, and then for section 1 1 if you consider, then what, and if I take the upper part of the section 1 1, then basically what we get? This is joint A. From joint A, AD force is acting, FAD, then joint A, FAB is acting, and joint A, FAC is acting, and this is the force 1000 Newton is acting perpendicular to the line AC. So, this is the free body diagram of the upper part of section 1 1. Similarly, you can draw the free body diagram of the lower part of the section 1 1. So, what I am doing by taking the section, I am taking out some part of the truss, and I am analyzing separately that part to get the unknown member forces. Okay. So, now similarly section 2 2, let's draw the free body diagram of section 2 2, which is maybe section 2 2 is cutting the truss in 2 parts, right hand part and left hand part. So, we will be taking the right hand part. So, let us see. So, if we take the right hand side of section 2 2, how it will look like? Let me draw it and then I will explain. So, this is the right side of section 2.2. If you look at the section 2.2 is cutting 4 members, as I told you, member AC, member AB, member BD and member BE, right. So, these 4 members are getting cut by section 2.2. So, if I am taking the right hand side or the right part of section 2.2, then basically it will look like this. So, that is my free body diagram of the right hand side of section 2.2. Okay. So, this is your, if you consider section 2.2. Now, you may ask me that why I am considering the right hand side. So, there is no hard and fast rule. You can choose as per your convenience or as per your actually requirement. You can choose the right hand side or the left hand side, there is no issue. Okay. You can choose even left hand side. Okay. Now, if you, now how you will find out the member forces. Now, for example, I am not going to solve the whole problem. For example, you know Hy, this is the force is known to you, that is externally applied force. Now, these member forces are completely unknown to you, right, you do not know these member forces, agreed. So, what I can do now, if you look at, there are 4 unknowns, right, there are 4 unknowns, but how many equations are available with you, equilibrium equations? 3, 2 force balance and 1 moment balance, summation of Fx equal to 0, summation of Fy equal to 0 and moment balance. Now, by seeing the configuration, as I told you, though the section is cutting more than 3 members, but depending on the configuration you may get the solution. Now, for this problem I deliberately took this problem to tell you that it is not compulsory or mandatory that all the times the section should cut maximum 3 members. Anyway, if you take the moment equilibrium with respect to B point is equal to 0, then basically from B point there are 3 member forces are getting out or they are getting emerged, right, FBE, FBD and FAB, all forces are getting out from joint B. So, if I take the moment equilibrium with respect to point B, immediately the moment of these forces will be 0, right. So, which one will be left out? FAC. So, moment of force FAC with respect to point B, moment of force 500 Newton with respect to point B and moment of force Hy with respect to point B, and if you take the algebraic summation of these moments, you will be getting the unknown force FAC, fine. So, once you know FAC, then basically if you come here in section 1.1, so now earlier case you had 3 unknowns, right. Now, you know FAC, because here actually the situation is lying in such a way that you are considering the method as good as method of joint, right. So, only one joint is considered, but as I told you in the previous lecture that from one joint if you have 2 unknowns, then basically you can solve, because if you consider the method of joints, at each and every joint you have 2 equations of equilibrium, summation of Fx equal to 0, summation of Fy equal to 0. So, initially you are not able to find out the member forces if you consider section 1.1, But once you know section FAC from section 2 once it is obtained, then basically if you come back here, now it is known to you, this force is also known to you because that is externally applied forces. So, therefore, you will be knowing these forces FAD and FAB. In that way actually you can solve the whole truss. Now, let us talk about section 3.3, how what information we will be getting from section 3.3. So, we are taking the left hand side of section 3.3. So, let us draw it. That is Gx, Gy, they are known forces. This is your G prime, G double prime as shown in the figure. This force is F E G double prime. This force is F E G prime, and this force is F D G prime. So, what are the known forces? Your known forces are this force, this force. So, these are the known forces, right. From the support reactions you know these forces. So, what are the unknown forces? All member forces. Now, you see section 3.3 is satisfying all the conditions whatever we just talked about, right, that it is cutting maximum 3 members. So, member DG prime, member EG prime and member EG double prime they are cutting. Okay. Now, if I want to find out the forces, the member forces, the unknown member forces, what we can do? We can simply take M G prime equal to 0, that is the moment equilibrium with respect to joint G prime, and if I make it 0, then basically the moment of these forces F dg prime and F eg prime will be 0. So, only force will be left out, that is F eg double prime. So, therefore, we can find out F eg double prime, right. So, once it is known, then we can take summation of F x equal to 0, summation of F y equal to 0. So, from these two equations we can get these two forces. So, initially we got this force, now we have got these two forces. So, all the 3 forces are now known to me. So, in that process, so there is no maximum number of sections, you can choose n number of sections. Okay. So, by choosing different sections you can simply get the member forces. You can jump on that particular section, you take the free body diagram of that particular section, left hand side, right hand side, upper part, lower part or whatever, right, and then you exploit your equations of equilibrium and then finally you will get the unknown member forces. I hope it is clear to you, right. Okay. So, now with this basically we can conclude the truss problem or analysis of truss. We will take some example, numerical example later on to understand the truss problem or to see how we can get the numerical values of the member forces. Now, we will move to the next topic, that is friction. This friction is mostly known to you, okay, from your previous background, that friction is very much discussed in the course of physics. Just to recapitulate or just for sake of completeness, okay, of the discussion, we are going to discuss about friction. Okay. Now, friction is nothing but the interface response. Interface response means, suppose I want to slide block A over the surface of B, okay, and this block is under the force of say P, and I am just trying to pull this block T with a force T, so that it will slide over the surface B. Now, at the interface between block A and the surface B, some forces will be getting developed which will try to resist this sliding movement, and that force is nothing but your friction, right. So, now we are well equipped to draw the free body diagram. So, we will draw the free body diagram of block A as well as surface B. Let us see how we can draw it. So, block A, the free body diagram of block A will look like this. This is your block A, okay. One vertical force is acting, and this is the horizontal force which is acting. I want to apply some horizontal force to slide the block A over surface B. So, these are the forces are shown here. Now, few forces are not shown. What are those forces? Now, block A is resting on surface B. So, therefore, B surface will give some action, or the if you call that action or reaction whatever. So, some vertical force, of course, that is a reaction, because block A is I mean placed over surface B. So, the B surface will give some opposite reaction, and that reaction say N. Okay. Now, when I am trying to slide block A over B, as I told you, as you know, that some frictional force will be getting developed, and that frictional force is opposite to the direction of movement, that you know from your physics. This frictional force is say F. So, this is the free body diagram of block A. Similarly, you can draw the free body diagram of surface B. This is your surface B. So, what are the forces are acting on surface B? This N is the reaction developed at the interface, because the block A is placed or resting on surface B. So, therefore, you are getting the reaction. So, you will be getting opposite and equal action on surface B, and F force, that is the frictional force, is acting at the interface between block A and B, right. So, therefore, F is acting in the opposite direction of the movement of block A. So, therefore, you will be getting a force F which will be acting like this. So, this is the free body diagram of block A, and this is the free body diagram of surface B. So, that means we are separating out each individual component from the whole system. Okay. So, I will stop here today. So, in the next class we will continue with friction, and then we will take some numerical examples to help you to understand what we have learned so far in this particular course. Thank you very much.